Andrew here again. Welcome to the next video in our Haas certification series. In this video, we're getting your Haas CNC mill up and running at the start of the workday. Here are the things we'll cover: powering on, safely homing the machine, checking the coolant level and machine cleanliness, starting and stopping the machine, and machine and job readiness. So let's dive in. So let's start with powering on. Many shops will power down their machines each night so they aren't drawing power sitting idle. Here at the back of the machine is where the circuit breaker is located, but this will almost always be left in the on position. It's also important to check that the air pressure coming to the machine is in the correct range. The air pressure gauge is visible at the side of the machine. If air pressure is too low, you'll get an alarm message on screen, in which case you should alert your supervisor. So let's move to the front and press the power on button. It takes a minute for the machine to do some diagnostics, and then we'll see the red e-stop light. The machine always starts up this way. This is normal and nothing to be concerned about. Now let's follow the on-screen instructions. We'll cycle the door so the machine knows that the door lock switches are working. Then we'll turn the e-stop button to the right and press power up. This sends the machine to its home position. You'll see the three axes of the machine all move towards one end of travel. You'll notice that the Z-axis always reaches home position before X and Y begin moving. This moves the tool out of the work zone before the workpiece can crash into it. Also, the tool changer on your machine will move to its home position during this time. So what does it mean to send the machine home? As we saw in an earlier episode, each axis of the machine has an encoder that keeps track of position. When the machine is first powered up, we need to establish a baseline, or home position, for each of these encoders. In other words, sending the machine home gives the machine a starting point for each axis. If you're working on an older Haas machine with our classic control, then you'll need to send the machine home using a few more steps than how we just did it automatically. You'll clear the initial alarms by pressing the reset button several times. Then you can proceed as before and press the power up button. Now, one important thing to keep in mind while homing the machine. The machine we're working on right here isn't in danger of a collision during the homing process, since there is just a vise on the table and a shorter tool in the spindle. But if you looked inside the enclosure and you saw this, then it's time to get your supervisor. In these kinds of situations, the machine needs to be homed in a more sequential manner, not in the normal automatic way. We need to do this one step at a time, anytime something might crash before all the axes reach home position. Until you're very familiar with this sequence, have your supervisor handle this step. Coming back to our startup screen, there are three things we can do at this point. We can hit cycle start, we can press hand jog, or we can press cancel to leave the startup screen. In our case, we are going to press the cancel button to leave the startup screen. At this point, we've powered up the machine. Set it to the home position. Now, let's check to make sure it's clean and ready for action. The table and the weight covers need to be clean of chips. This machine here obviously is clean, but if you see something like this or this, then you'll need to get the machine cleaned out before the start of the workday. It's important at the start of the day to check the coolant level in the machine. Insufficient coolant can lead to premature tool wear, tool failure, and bad parts. So let's press the memory button. In the top right-hand corner, we'll see the coolant level readout. We can see that our coolant level is right about in the middle. But let's double check this at the coolant tank just to get a feel for how full the tank really is. Walk to the back of the machine and pull up this cover here on the coolant tank. Sure enough, the coolant level looks like it's about halfway full. Now, it's best if we get this to at least 3/4 full before we start machining any parts. And remember, if you're working on an older machine where the coolant level sensor might be disconnected, then checking the coolant here at the tank is a must-do every morning. Also, since we're back here, we can take a look in the chip catch tray. If this is full of chips, then we want to empty it out into the chip bin before we get started. If we allow this to get packed up with chips, it could slow down coolant flow back into the coolant tank. Let's look at how you stop and start the machine. This idea is central to how we control automatic motion. When you're ready to start running your part, you will press cycle start and the machine will run automatically until the part is finished or the operator stops the machine for some reason. I'm going to start the program right now. It's not cutting any metal at the moment, but we'll use it to show how to stop the machine. Once the machine is started, there are 3 ways you can stop it. The first is feed hold. Pressing feed hold stops all axis movement, but does not stop the spindle. It's like pressing pause in a video. You can look at what's happening inside the machine to see if everything's okay. With my program running, I push feed hold, and all the axis motion stops. And we also see that the program on screen has stopped, but the spindle is still turning. When I'm confident that everything is all right, I just press cycle start again, and the machine starts up right where it left off. We'll talk more about using feed hold later in this series. The second way to stop machine motion is to press the reset button. If you press reset, while a program is running, the machine will stop immediately unless it's in the middle of a tool change or tapping cycle. After machine motion stops, the program will reset to the beginning. This is not the button you should press in an emergency. The third way to stop the machine is to press the emergency stop button. We call this E-stop for short. This is basically the panic button. Anytime you think you are in danger or you think the machine is about to crash, or worse yet, the machine has already crashed, press E-stop immediately, and the machine will instantly halt, and everything will stop, including the spindle or tool changer, even if it's in the middle of a tool change or cutting a part. Some shops will want you to E-stop the machine anytime you walk away for an extended period of time, like for lunch or break, or when you leave for the night instead of powering the machine down. This leaves the machine in a safe state where no unexpected motion can occur. Ask your shop supervisor what their policy is for engaging E-stop during breaks. Many shops will start their machine first thing in the morning running what we call a spindle warm-up program. This simple program starts the spindle out at a low RPM and gradually increases RPM over a period of minutes to get the spindle warmed up before actual cutting begins. Check with your shop supervisor whether they run this kind of program before the machine starts its first job for the day. Finally, let's check that we're ready to run our part. Here we're assuming that the machine will be set up by the supervisor or setup machinist. Therefore, everything should be ready to run when you get to the machine. Each shop's supervisor or setup machinist will prepare their machines differently, and they will tell you what to check before you start running a job. But here are some common things to be familiar with. Is the vise or fixture installed and tightened to the table? Do the jaws look parallel to the table's T-slots? In other words, is the vise or fixture lined up to the machine table? In later episodes, we'll learn that just because the vise looks square to the table doesn't mean that it actually is. Is the stop that will be used to locate the part attached tightly to the vise or wherever it's mounted? The correct program should also be loaded. You can see what program is loaded by pressing the memory key. This number here at the top is the program number. The tools used to make the part are often listed in the beginning of the program. The tools for the program should be in the machine and be in good condition. This isn't something that you'll be checking in the beginning, but just realize that it is a requirement before the job can be started. And finally, the raw material you'll be using for the job should be ready beside the machine. We'll cover these and many other related topics in more detail in later episodes. These are things the supervisor will set up in the beginning, but that you will quickly become familiar with as you work on the machine. That's it for now. Next, we'll be looking at loading, running, and unloading our parts.